So that's all then, I think. So without wasting any more time, I would add Pulkit Agarwal from GitHub.
Hey, can you guys
Hi,
hear me
Pulkit.
well?
Yes.
Hey,
How are you,
hi.
Pulkit? How are you doing?
I'm doing all right. How are you? Thanks for inviting me
I'm
over
doing
here.
good. I'm doing good. We are really excited, Pulkit, for your session today, and we had a really nice time in the morning with our forenoon sessions. So we had
Mm-hmm.
3 sessions in the morning, and you're going to start with our afternoon sessions. So
Okay.
we are really pumped up, and our participants are really waiting for you to start this session. So going
All right.
further, Pulkit, would
Mm-hmm.
you like to give a quick intro about yourself, what you're doing, and what the session is going to be today?
Absolutely, absolutely. So first of all, thank you. Hello, everyone. Good morning, good afternoon, good evening, and thank you for taking out time for this one. Thanks, AI Dev team, to inviting me over here. So I'm a product manager at GitHub right now, and one of the initiatives that I'm working on is to make the life of data scientists easy as to how they can bring their models from their local machines to Azure and productize that and make sure that the world is able to use them. So that's the mission that I am pursuing right now as a part of my product manager journey. And over here in this next half an hour, 35 minutes, we'll be talking about some sneak preview of what we have been working on. At the end of it, I also have a demo where we will just showcase you that how would MLOps be implemented in your organization. And obviously, I'll break down what does MLOps mean in sense for you to decode that. And we should have some time for Q&A. And over there, I think I'll require Rohit's help to just guide with whatever appropriate questions over here. Sounds like a plan, folks?
Definitely.
Okay, perfect. Perfect. So I am sharing my screen right now.
Sure.
Let's see if we can.
Just waiting.
Yep.
Yes, I can see
Wait.
that. Yes, I'm just putting it on the screen.
Mm-hmm.
Can you see?
Awesome. Awesome. All right. So I think I'm assuming audience are also able to see the screen. So I'll get going. Perfect. So I think with that introduction, right, let me just dive right in as to the first word. What is MLOps? Wow. So I think the simple answer could be MLOps is nothing but applying DevOps principle for machine learning application. But the slide itself begs another question. What is DevOps? So from that perspective, let me just take a deep dive into what is DevOps and how do we understand DevOps. So DevOps is a union of people, process, and technology to deliver continuous value to customers. And if you see the phrasing over here right now, we have intentionally chosen some words, and I would like to double click on that a little bit more. So the first word that I want to highlight over here is value. So the goal is to not talk about shipping software, but shipping value to the customer. And that is one takeaway that I would like the audience to have right now. The second one that I would like to purple up over here is that we are talking about end consumers or customers right now. And where we are saying that if we are shipping something which is reaching our dev stage or staging stage or pre-prod stage, then it means that we are somehow not being able to deliver that value to the customer, or till the time we are able to make those changes reach production, the value has not been percolated to the customers. So with that context, I wanted to make a statement that DevOps is not a product. You cannot install DevOps in your organization and say that I am DevOps ready. DevOps is an automation, just not just an automation. You need to make sure that people are there, they are following the processes which are enabled by products that are delivered. So I think with that context, with that definition, let's move in, right? What would MLOps be? So if you were to revisit our definition of MLOps, we can say that MLOps is a union of people, process, and technologies to deliver continuous value to users. But the caveat is that we need to use, or we would be using, a ML-based software application. So with that paraphrasing, let's move ahead. I think the team over here should have some context of what MLOps is. Let's just quickly move ahead over here and see what are the next steps. So now the question that sometimes ponders me, and I have spent some time on it, and I'm assuming some of you folks will be having, is that, hey, why is MLOps challenging? Is it at all? And the reason for that question typically comes to me and from the customers also, is that DevOps tools and practices have been in their industry for some time now, and we know how to implement DevOps practices in the organizations. How somebody should manage their code in version controls, like for example GitHub, or how CI/CD pipelines can be used, or should be used rather, to build and deploy the application to production. And if that is the case, that is the background that we are coming from, why should MLOps be any different? Well, if that is the goal and that is the question that we would like to answer, let's try to double click on this and see if we can understand the life cycle of an ML application. And let's try to understand a little bit more on what challenges would the customer be facing, and if at all MLOps is challenging. So let's embark on. So let's take a pause. And if I were to just talk about machine learning, the first thing that I've heard from customers, as well as it has to come in my mind as well, is that, hey, that it is about building a model. But I want to bubble up something which is very striking. Building a model is a very small piece in the wheel of the entire machine learning process. Let me give you a quick example and to show what I mean. So these are all the things potentially a customer has to do for them to be able to build a machine learning application and make sure that it is in production. There are too many words, so I won't go in details of it. I'm pretty sure that most of you are aware of it, but if not, we can definitely go in a little deeper later on. But on a high level, I'll give you an example which will help you appreciate the problem which data scientists or developers face today when they are building or deploying a machine learning application. So let's say, for example, we have an application which is scat or not. So the typical application that, hey, if I'll train a machine learning model, and I'll give that model an image, and the model will run on that image, and result will be either a cat or a not. I think that is a typical model that we can think of. So what does it take today to get this kind of a model in production, which is a very, very basic model? So I think the first version of it is that a data scientist has to scrape a lot of data and prepare the data from different sources. The data can be coming from a CRM, the data can be coming from a knowledge graph, the data can be coming from a publicly available data set, IoT edge device, etc. So those are a lot of sources of data where we can consume data from. Then the prepared data, if I can use that word, is stored in a database. And the database could be a blob storage, a data lake, a Cosmos DB for training purposes. And this is the data which is being used by your training script when you are building the model, what we used to traditionally believe what building a model means. And the data scientist over here would be using a lot of different IDs. So potentially the typical most favorite ID I have come across is Jupyter Notebooks and PyCharm. But to my surprise, I have seen a lot of people use Notebook and Notepad and Notepad++ as well, where they write their Python script to consume this information. So the output of this potentially is that I would like my machine learning model or Python script that I have written to train on this data set that is present potentially in a blob storage and give me an output, which is basically the next step. So what we are saying over here is that there are training job that will be run, which potentially can run on a small box, which is your local system as well, if the training set is small. But it may require a powerful or more powerful training environment, assuming depending on the size of the data set and the complexity over there. And the powerful data set, powerful machines can be a powerful VM, or it could be a Spark cluster, it could be Databricks. I've also seen Kubernetes cluster being used sometimes to train the models. And obviously, depending on your needs, if it is deep learning, you might need GPU-based devices and hardware as well. The output of this training phase, so to say, is a pickle file, let's say, for example, which is traditionally called a model. And now the model has to be consumed by the application, because at the end of the day, a model is as good as how well it is getting integrated with the demandant. So from that perspective, there are a few ways in which model gets productized today, or what we call as operationalized today. They are either deployed as an API, or they are embedded as a package in an IoT device, or they are embedded as a package in an existing service for a mobile application, let's for example. So let's take a pause over here and understand that if we were to do really ML ops, we would have to build tools for automating this process and automating in such a way that the value is delivered to the customer on every chain in a very effective manner. And that's when we will say that we have been able to achieve ML ops. So with that context, let me move a little bit ahead. So obviously, I'm assuming that with by now you would have some context on the friction points that we will observe when we are thinking of MLOps or implementing MLOps. But let me be a little bit more explicit right now of some of the challenges. Obviously, there are more. For example, one of the biggest challenges that I see right now is collaboration on code. So remember, we were talking about the data scientists use today their favorite IDs. But the collaboration is not easy over there. For example, you're using Notepad. There will be a lot of cases of conflict that you have to manage across your team, and that can become a nightmare very easily. The second one would be, let's say, remote training. So as I was mentioning earlier, that one needs to connect to a remote computer, move their code over there, make sure that the remote data source and the training compute that you're talking about has a line of sight, and there is some hooks and balances that you need to take care of for that to actually even work. Then there is model bookkeeping. So today, data scientists find really, really hard to back up their models or move back to an older model. Most of the training is happening today in the local machines. And it is on individual how they are maintaining the versioning copy of it. Then the other one is many, many manual steps. I think, as I said, I think this is given that there is no automation process right now. So because of that, there is the entire process has to be manual. And there's a lot of handshake. Let me give an example. For example, data scientists may not know as to what is the best way of converting a model to an API. He may not know, he may not be able to write the best controller files that gets invoked on an API call, and that to write in a scalable manner. So that is a handshake between a data scientist and a developer, let's say, for example. And last but not the least, obviously, is managing code and data updates. So we have trained a model once. Let's say, for example, after doing a lot of this jigging, we are able to move the model to production. But the code change or your data change. And if that change, one of the biggest problem is that how do we run the entire cycle again? So that, and more effectively, how do we run it automatically so that the training and deployment of the models and moving those models to production can happen with the latest version, what data scientists have prepared. So just taking a pause again to make sure that people internalize the complexity that we are involved, and saying something that, hey, that this was my reaction when I started thinking about this, and ML ops sounds really hard. And that's where we thought as a team that let's make some difference. And that's where we are coming into picture, where we are saying that let's make MLOps easy. So while I made that statement, I started realizing that that's a very ambitious one, given that the state where we are in. So what I thought was that let's make it easy-ish instead of making it easy and be a little bit more realistic. So that what I will be talking about a little bit more over here is that how do we intend to make it easy for customers to at least get started and have an entire end-to-end cycle running. So what does it take? So for example, we were talking about making it easy right now, right? To solve this problem, what you would need an ML optimized compute, which can be used for training and storing the model, a source control, which can be used for collaborating on training code and collaborating with a fellow data scientist and maintaining the versions of history of your code changes, and a CI/CD pipeline, which is ML aware, and that's important, which will automatically move your code to cloud, and that get also triggered once a data set has changed or drifted or a code has changed. So, and that's where Azure ML comes into picture. That's where GitHub comes into picture, and that's where GitHub Actions come into picture. So with this, I would like to take a pause again and potentially move to a demo where I would like to talk about how can we help customers today on how have we really released the functionality, or how can we help customers today to do this entire process on their own. So let me stop sharing. I have to share another screen so that I can move to a demo slide. Give me a second, folks. I'll project that one. In the meanwhile, yeah, feel free to log into this one. This has instructions of what we'll be talking about. and we can do that parallelly as well. So I am pulling up the slide that I want to share. All right. Sharing this again. Awesome. Folks, I have shared this again. I believe, Rohit, you might have to do something to make it work. Awesome. Thank you. Okay, so this is where we are right now. So I think if you would have clicked on that link that I have shared with you, you would have landed on a page like this. So this is our template repository that we have created, which will allow you to set up all this that I've talked about very easily for you. So this is the button that you need to use. And let me quickly walk you through the process and make sure that we are on the same page what we are talking about. So you click on this, you use this template. It will nudge you to create a clone, and this is where it will be. And this is the README file that you need to follow. So there are a few prerequisites, given that we are talking about GitHub integration with Azure ML. You would need an Azure subscription. There is a concept of contributor access to Azure subscription. We would need that. And obviously, because we are talking about GitHub Actions, you would need access to GitHub Actions in your repository. So let's say, for example, I have access to an Azure subscription where I have created what we call as a resource group. So resource group is nothing but a logical grouping of all the resources which you can have for those to manage them better. Given that this Azure is, we need to integrate between Azure and GitHub. What we need to do is that we need to provide some Azure credentials and path tokens. So Azure credentials is nothing but, and obviously this README file has details of it. So I'm just walking you through what exactly you need to do, but these are the same steps that are mentioned over here in the README file. So these are the secrets that you need to create over here so that GitHub can talk to Azure and Azure can talk to GitHub back. So with that plumbing in place, what I'll do is that this is a workspace.json file, which is the definition of your AML workspace, a concept, or Azure ML, which you need to define, where I need to provide this resource group that I have created over here. And if I do that, I can actually have a GitHub action setup done, where I will provide my resource group over here. And as soon as I click on commit, it will trigger execution, which will create this workspace for me. So with that, let me take a pause again and drill down what each of these concepts means. So what I'm talking about here is that if you edit this particular file, we are talking about a YAML file right now, which is the definition of my GitHub Actions workflow. So GitHub Actions is a set of steps that will be executed on a particular event. For example, the events over here is any change to this particular file. And because there is change to this particular file, these will be the events that will be triggered, which potentially does is that, hey, it checks out the repository where this particular set of file is defined. It does an Azure login. Remember, we actually created our Azure credentials over here. So this is how GitHub is able to talk to Azure, and this is where we are setting up the entire configuration for you to be able to talk to Azure ML workspace. So that if you look at a little bit over here, these are parameter files. These are parameter files, which means that your configuration or Azure ML workspace that you have created over here are defined in a JSON file, which means that those configurations are also defined as code. So tomorrow, if you want to change the configuration, you can go to those JSON files and update that. And as soon as you update that, again, this particular deployment process will get triggered. This particular workflow will be executed, and these workflows will update the template file using the template file, the AML workspace. So I have already made this commit in past, and because of that, what has happened is that our setup update has been triggered. So if I can show you the commit over here, so you will see that this particular commit was the one that I created earlier. And this commit triggered this particular workflow execution, which ended up being executed and creating this ML workspace for me. So this is the one that I wanted to bubble up again, where we were talking about that this is the template that has been used to deploy. And this is what you can update in case you potentially want to make any change to your AML workspace. So what we have right now is that we have an AML workspace ready for you to get started. Now, what we need to do is that, again, this is again present in the README, that we have set up our trigger, and we can define a trigger right now. So in our deploy.model.yaml file, we have configured a trigger. What is this trigger? So remember, one of the problem statement that we were talking about was that the training has to happen on a more powerful machine. So what we are doing today is we are using Azure ML to do that training, but GitHub has to know that when the training is complete, so that the GitHub can execute rest of the workflow for GitHub to be able to deploy that model as an API, for that API to be available for your dev partners to integrate your application, to integrate your model in their application. So this is what that plumbing does, where as soon as your machine learning service has done completed, which is the code name or the in-house event that we have, where an event is triggered, which triggers this particular pipeline, and this particular pipeline does the model registration part, which is storing the model, and then deploying this model over here in an ACI instance, and that similarly in an AKS instance. So with that context, let me just quickly show you that, hey, this is what has happened over here in the train.model file. So in the train.model file, what you'll do is that you will just be running the training job, which will be triggering the training at Azure ML side. And as soon as this training is done, this particular file will be initiated, which is deploy model file, and that will deploy the model. So over here, what I would like to show is that the same thing that I have done, again, a small commit, given that I did not need to make any specific changes on this file, I just added a small blank space over here, which triggered this workflow file for me. And after this workflow file was triggered, my machine learning run completed was also triggered, which if you see over here is repository dispatch event. So what you're talking about over here is an automated way in which your machine learning workflow can be set up on any code change. So let's just take a detailed example of this. So this particular one is the update training model. And over here, if you see, you can also get the API where you can hit your model to be executed. So, and we also have a Swagger API, so which will tell you the payload that you need to pass to this scoring endpoint as a post request for you to be able to construct a request. Okay, so with that out of the picture, right? What next? So I think one of the other things that I wanted to tell you was that this is just a part of where I have showed you a dummy commit. But what you can also do is that you can make, let's say, for example, some major changes. After I hit my Swagger API from here, I realized that my model is not producing enough appropriate output. And I realized after debugging that the test size has a glitch. So I update my test size from 0.2 to 0.8. And this is the model that I have used right now is Iris. And it will obviously, I think people would know potentially that it will tell me the type of flower. Very similar to type of cat that we were talking about earlier. So it will tell me the type of flower, and I see there is a bug over here. So as soon as I make this change, there will be another execution which is over here that will update my training script, and the same updated model will be deployed over here. And if you see over here, after that, once the updated model has been deployed, if you go to that URL again, you will get an updated application. So this is from the perspective of what will happen when the code has changed. Now, coming to the perspective, I think I'm just looking at the clock right now, and I'm trying to wrap it up, making sure that we have enough time for Q&A. That we can also, what we do is that you can also do something similar for storage triggers. So as we said, right, a model right now has two potential input. The first input and the major one is the application code or the training script code, and the other one is data. That if the data change, if I have new data and there is a data trigger and the data drift, I would like to make sure that my model is trained again and the new trained model is deployed again. So in the same repo, what we have done is that we have given you very easy way to comment out or comment in some of the changes over here, which will make sure that if there is any update to the Azure blob storage, for example, I have created a blob storage over here, a storage. So if there is any change in configuration over here, and containers over here and configurations over here. If I create a new container and create new data set in that, it will trigger my pipeline again. So that is the end-to-end story of how you as consumers will be able to simply use this repository, clone it, and have an end-to-end pipeline working for you right away. Obviously, it has some sample codes. You can change the code over here and include your own application code for this to work. With that, I will take a pause again and happy to answer any question that you guys have right now. So I think one of the questions is that how can we change the triggering action to run by commit to something else in order to, so perfect. So GitHub Actions today support a lot of triggers options. For example, the one that I showed you was on dispatch event. But if you see, there are multiple YAML files, and one of the YAML file was triggering on commit. And the other YAML file was getting triggered on a repository dispatch event that is coming from outside. Similarly, you can also do from code push. You can also do from PR. You can also do from an issue being created. So there are multiple ones that they are getting supported. Thank you, Shubham, for the question. Anything else, folks? All right, perfect. So I have a question. What knowledge a DevOps SRE engineer need to acquire for transition to MLOps? I think, so there are two things that I would like to call out. One is that the change in mindset. The mindset perspective that there is a lot of context of ML that has to be learned, and to make sure that you are able to have an effective communication with the data scientists. That's one. And second thing, the biggest change that I have seen between a traditional DevOps process and a machine learning application process, or MLOps, is that the process are a little long running. So if you see, one of the reasons we have modeled the way we have modeled right now is that the training can happen for hours and for days. And you have to make sure that the systems that we have in place or the processes that we have in place takes care of it. So the way we have architectured our solution right now, if the solution is getting trained for, let's say, 5 days as well, we will still receive a notification on the 6th day on the deploy YAML file for them to be executed. So as I said, right, it's a mindset change from a people perspective, process perspective, and tooling perspective. Tooling perspective, we have taken care of. From a people perspective and process perspective, you have to make sure that you understand those concepts a little bit more, understand what does building of ML mean, or what does a deployment means over here. And with that, I would assume that you should be able to have a great communication with the counterparts that you have. Thank you for the question. Is TensorFlow serving being considered MLOps? Absolutely. I think MLOps, as I said, right, it's not dependent on a tool. So tools will be able to do only a bit of it, and it's also an amalgamation of process and people. So TensorFlow also is attaching or trying to address the same problem, and but it depends on how effectively are you able to manage and adopt to TensorFlow and being able to incorporate that. So that is one of the things that we have tried and found that customers face today, and that is the motivation behind building this template repository for you to be able to build this application and deploy this machine learning application in a very fast manner. So yes, TensorFlow serving should be considered as MLOps, but it depends on how effective and how easy for you to get started with MLOps over there. Thank you for the question, Shubham. Anything else?
I think that's it for now.
Awesome. All right, I think we are running out of time as well. Great, thank you. Thank you for having me over. It was lovely meeting you guys over here as well. From my side, I think you guys can reach me at Pulkit p.agarwal@microsoft.com, or my handle is present over here as well. So from that perspective, I'll do a sign off from here. I love to hear any feedback that you guys have on this repository and see if any guys are still facing any challenges. Feel free to raise an issue over here in the repository. I'll be more than happy to engage with you guys. We are here to make sure that you have a successful ML application deployed in production. Thank you.
Awesome. That was a really cool session, Pulkit. And there are still few questions pending. I think you or Karan will be answering them. Also, I would
Sure.
request Pulkit to share the slides so that we can share it with our audience
Absolutely.
and they can access that repo.
Absolutely.
Awesome. And we have already updated your social media link on the website. So people will be reaching out to you over social
Sure.
media.
Sure.
Yeah.
Happy to help.
Awesome.
Thank you.
Awesome. Thank you, Pulkit, for joining us today.
Cheers. Bye bye. Have a good day, guys. Have a good day.
Okay. Thank you.